RM deletes a file, shred destroys a file, mkfs, that destroys the entire drive. Not the files on it, the drive itself. The file system structure, partition tables, data, everything. One command. No warning, no prompt, no undo. Today we're talking about mkfs. Now this stands for Make File System. It's the command you use to format a storage drive. A hard drive, an SSD, a USB, partition, any type of storage device. A fresh file system structure onto it. When you format a drive, four things happen in sequence. First, it writes a super block, the master record describing the file system, size, type, block count. Second, it creates tables, the index tables the OS will use to track every file on the system. Third, it marks all spaces free, making it ready to be written to. And the one that matters, it destroys the old system. The previous file system metadata is gone. Every file that was on the drive becomes unreachable. That last step, it's going to happen whether you mean it to or not. Before the command itself, you need to know that mkfs isn't one thing. It's part of a family of commands, one per file system. The type that you pick determines your data in organized, protected, and accessed. Choose it intentionally. On this screen here, you can see the command broken apart. mkfs.ext4, that's shorthand for mkfs-t ext4. It formats the target with ext4. The -L, my drive, sets a human readable label. Now that's actually optional, but it shows up in file managers and lsblk outputs. -B 4096, that sets the block size. It's the default for most use cases. /dev/sdb1, that's your target. This is where the danger lives. One letter wrong, and you've wiped the drive. The last point cannot be overstated. /dev/sda versus /dev/sdb, that's just one character. On many systems, SDA is your boot drive. Know exactly what you're pointing it at before you run it. Now let's take a little walk through it. This is a safe, intentional format on this screen. Before running anything, you run lsblk first. This shows every attached device with its size and mount point. You can identify your target by size. You confirm twice. Then fdisk-l for detailed partition info. Confirm the exact path. If the device is mounted, you unmount it. You mount /dev/sdb1. Formatting a mounted device causes corruption. That step is not optional. Then the format runs. You can see the output. It creates the file systems, allocates the tables, writes the tables, creates the journal, writes the superblock. When it says it's done, it's done. Then you mount and verify with DFH. Fresh file systems ready to use. The sequence is look, confirm, unmount, format, in that order, every single time. Here's what separates mkfs from what we've covered before. Now RM, that works on your files. Shred, that works on a single file's contents. mkfs can work on an entire partition or device in one shot. There is no confirmation prompt. There is no I flag. The moment you press enter, it runs. The worst case, and this has happened to many experienced users, is typing /dev/sda instead of /dev/sdb. One letter, your system drive, gone in seconds. I would know. I have made this mistake before. I'm not ashamed to admit it. And unlike Shred, mkfs, it don't overwrite your data. You can recover it possibly, but it'll be partial, unreliable, it's kind of expensive, and it's really not something you should count on. Run lsblk before you format, every single time, no exceptions. Now mkfs is a tool for intentional deliberate work, setting up a new drive, reformatting USB sticks, preparing fresh partitions. If used correctly, it's something you'll use regularly and with confidence, but used carelessly, and it's the end of the drive. Drop a like if this was useful, subscribe for more, and I'll see you in the next episode. And this has been brought to you by Red Wolf Studios.